What I want to talk about today is really coming out of a request that I've gotten from quite a few people about calibrations. And before we do that, let me tell you, I point out a little bit on why that is and how that whole fits in. When we talk about CPT, and you've seen this screen numerous times before, we push a cone into the ground at a continuous rate of 0.8 inches per second or 20 millimeters per second, and we record the tip, the sleeve, and the pore pressure every so often. And we do that in a very organized, very standardized manner. Standardized because while we don't take any samples, we want to be able to do something with that information. And therefore, in order to get a good correlation, everything has to be standardized to the nth degree. And you see here one example from the ASTM standard, but the dimensions are exactly the same thing in the ISO standard, where we talk about the tip and really indicate very specifically what the tip diameter is, what the height of the tip is. Everything is very well prescribed. As I said, this is from ASTM 5778, the standard for electrical CPT, but you find the same information in the ISO standards that you see here on the screen as well. But those two standards, even though they are different, are basically describe the CPT process in more or less the same way, so you can use the same equipment and the same procedures around the world when you're dealing with electrical CPT. And here you see those two document numbers. Focusing then on the ASTM standard, one thing that I've pointed out in the past is that in the ASTM standard, there are about 94 uses of the word shall, which means that we are having a mandatory requirement. You shall do this, you shall do that. And that ties in with the whole concept that we're trying to make CPT a standardized process so that everybody uses it in exactly the same way. And therefore, we get results that we can compare, that we can correlate, that we can do something with. All makes perfect sense. And that's just as a reminder, because there are so many mandatory requirements in there, don't rely on a presentation or a short summary of the standard. Take the standard itself, get a copy and read it so that you do the things properly as they are prescribed in the standard. But then it comes to calibrations. And again, today I want to focus mostly on the ASTM standard. And in the calibrations, in the section there in 10.1.3.1, it says that for cones used regularly, periodic calibrations should be performed. The calibration period can be based on production footage, such as once every 3,000 meters of soundings or time period. And if calibration equipment is not available in the field, the cone may be checked in the laboratory at the end of the project, during which the calibration period is ended. And then it goes on in the next section that cones that are used infrequently should be calibrated based on a time period. And if a cone has not been used for a long period of time, checking before use is advisable. Now, what is so weird about this whole thing is that, as I told you earlier, you have 94 instances where the standard says, shall do this, shall do that, all mandatory requirements. And then when it comes to calibrations, it should, or may, or should, or advisable. In other words, suddenly the code that is so specific about everything else turns into something that is very vague. And the user or the owner or the person who is prescribing CPT is kind of left hanging. When is calibration required? And how do we define it? How is it going to be done? Now, let's look a little bit about what calibration is so that we get a better feel for why the code is doing what it's doing. Because the purpose of this presentation is not so much to tell you that the code is the only solution there is, that it's absolutely 100% right. There are suppliers that calibrate on a regular time frame, do it once every year or so, but it's more important that you understand where the code is coming from. In order to do that, it's important that we first figure out, get a better understanding what calibration really is. Obviously, calibration is a process is used to maintain instrument accuracy. It makes perfect sense. And that you should do calibration to make sure that those measurement results are within an acceptable range. Well, and that means that you configure your instruments such that that is being done in that way. And then it's common practice to get the instrument calibrated at defined intervals by a third-party calibration service provider who provides a calibration certificate, regular intervals, and a calibration certificate. Yeah, those are kind of the things that, when it comes to calibration, give you an understanding why we do it and what it involves and how it should be done. But then let's look at what's happening with CPT, with cone penetration testing. There, we do something completely different. Before and after every sounding, we check the calibration of the cone. We don't calibrate it, but we check the calibration. And we don't do that just in a time span, say every 3 months or every 6 months. No, every single time that a cone is being utilized for a sounding, before and after we check that calibration. And how do we do that? Through so-called baseline or zero load readings, where we basically have the cone hanging free, kind of illustrated on the left-hand side, where there's no load on the tip, no load on the sleeve or on the pore pressure transducer, and we check the 0 points, the zero load readings, and check whether that reading is close to the calibrated values. Before we start pushing the cone, we make sure that we have those zero readings that we take then, that they are within 5% of the full scale output from what the calibrated values are. So we allow some drifting, some changes in there, but they are very, very limited to 5%. Then we push the cone in the ground, and when it comes back out of the ground, before we finish our whole process, we again have the cone hanging free, and then we check again those zero readings, but then we compare them with the values before we push the cone in the ground, and they should not differ more than 2% of the full scale output. In other words, before we push the cone in the ground, we check that the calibration values or the zero values are close to the calibrated values. And then after, we check that during the process of the CPT, nothing happened to the cone, and that the cone is basically in the same shape as it was when it went into the ground. That's the process that we follow with CPT. So before the sounding, we know that the load cells appear to be in good shape. And I say appear because basically what we're doing, we're only checking 1 point. We don't check the whole calibration range. We don't go from a zero load all the way to a full load on the whole thing, but we check 1 point. And if that 1 point is acceptable, then we say, well, on that basis, we think that the cone is in good shape. And then after the sounding, we try to check. Again, not with 100% certainty, because there is a possibility that something else has happened, but at least as long as the zero readings are consistent, we think that we can say that the cone was not damaged during the sounding. Once again, those checks are not perfect because we only check the zero readings. What do we do with those zero readings? Well, here you see a cone calibration certificate with all kinds of information, how it was originally calibrated, when it was calibrated, what kind of tool was being utilized, all kinds of specific readings on that. And then we have a table where we show those 0 points for the tip, the sleeve, and the pore pressure. And then obviously during calibration, we go all the way to the maximum value. But in this case, when we during those zero readings, during those baseline readings, we only check those 0 points. So in other words, when you look at calibrations, With CPT, we don't feel that it's necessary that, or at least the code feels that it's not necessary, that we do a calibration every so often. Because in that case, you check only every so often that the cone is in good shape. We do a calibration at T is 0, then we come back, say, after a year, or after 6 months, or after a year and a half, whatever the time frame is, or if we have pushed the cone so many meters, and then we check again, is the cone in good shape? Instead, what the CPT process is that we, every single time that we use the cone, we check that it is in good shape, before and after. And if we find out that the baseline readings do not meet the requirements, in that case, we feel that, well, you need to start doing something. Yeah. And now suddenly, what you see now, because we're now talking about 10.1.2.4, if you should say that if the baseline readings exceeds those criteria, in other words, if we don't meet those tight criteria that we have, the cone shall be inspected. So now suddenly we go back to mandatory requirements. And if there's apparent damage, the cone shall be cleaned and damaged parts shall be replaced. So suddenly, once those baseline readings don't meet the requirements, we again go back to the standard, what we expect from the standard, very mandatory statements. This shall be done, that shall be done. And then when you replace those parts, you can do another baseline reading. If you find that at that time the baseline readings meet the requirements again, fine, no problems. But if not, then you can no longer use the cone, and again, shall no longer be used, a mandatory requirement, until it has been repaired and then completely recalibrated. Now, this is what the ASTM standard is saying. But one thing that's very important to remember when we talk about calibrations, local regulations or client specifications may overrule the ASTM standard. We have numerous instances where a local regulation or a national regulation says you shall not use any instrument that has been calibrated more than 6 months before or more than a year before it's being utilized. That obviously overrules the ASTM standard. Same time, we've had instances where that local regulation is there, and we would go back to the regulator and say, listen, this is the approach that we have with CPT. Are you willing to give a waiver for CPT? And in some cases, they said, yeah, that's fine. We understand now the logic. Or the case they said, no, we have the mandatory requirements that you do it, and therefore we will overrule what you have. So this is where we are. But I want to bring up one more point in this whole thing, and that is that it's always better to be safe than sorry. You don't want to travel to a job site for hours and hours, or sometimes more than a day, with a questionable cone, only to find out that it doesn't pass the baseline. And for that reason, there are people that say, well, listen, irrespective of what the code says, I should still calibrate my cone within every 6 months or every year. I don't think that goes far enough. I would go one step further. Use those baseline readings. Start looking, not only the code requires that you save them anyhow, that you record them, but start looking at those things. Because if you start seeing that the baseline readings start to drift, that the baseline reading before you do the cone testing, before you do the cone sounding, which is allowed to be more than 5% different from the calibrated values. If you start seeing that they first differ 1%, and then a month later it's 2%, and then 3%, and they slowly creep up, then you kind of an indication, guys, something is not kosher. The other thing is, if you have a cone that barely passes because it's, say, 4.5% different, my gut feel, my suggestion would be, don't try to use that cone again before you check it out thoroughly. Because if you're just barely passing it, it's good for that time, but it gives you an indication that something may be wrong with that cone, and you want to be better safe than sorry. Now, I told you that the ASTM standard is what I've used so far and made those references to that. Basically, since this is for an international audience, want to briefly talk about the ISO standard and say what is there. This is what table A1 from the ISO standards is saying, and you see in there what you have to do and what you have to do. Start of the test, at the end of the test, and you see your zero values test there again, and then of course every 6 months. And at first sight, yeah, it appears that the ASTM standard or the ISO standard is a little bit more specific, because it states in there that you shall do a calibration every 6 months, or at intervals during longer term testing. Now, so at least every 6 months. But then it also says that if it appears from a track record that no significant deviations are registered, a longer period between calibrations can be applicable. And that brings me back to what I was saying just a minute ago, that you look at your baseline readings. If from those baseline readings you see that, hey, my cone is in good shape, there's really absolutely no reason to worry about it, then a longer period between calibrations can be applicable. So the ISO standard puts a little bit more onus, if you wish, on really looking at those baseline readings. ASTM standard doesn't really say that in that many words, but that's what the hope is that people do, that they look at those baseline readings, that you don't only keep records of the baseline readings, but also review them, analyze them, and see whether you have any outliers. So, what are the conclusions? You have to do a baseline reading before and after each time the cone is used. And on that basis, CPT assesses the need for recalibration. So we don't specify a recalibration period per se. Every time that we use a cone, we figure out whether recalibration is required, yeah or nay. Those baseline results provide excellent feedback, what's happening with the cone, but only if you analyze them. And quite often what I see, I did an audit not too long ago, I asked them, do you have all the baseline readings? They handed me a folder, nicely printed out, dated, everything there, what the project was. I said, did you look at them? Nah, we print them and we put them in the folder and that's it. Well, that's not really what I would recommend. And then finally, please make sure that you follow the local regulations, because irrespective of what the ASTM standard says, irrespective of what I'm suggesting you do, irrespective of what the practice is within your company, if there's a local regulation that obviously supersedes whatever we're doing. And with that, I've come to the Q&A part of this session. And I'll just try to answer some of the questions in the remaining time that we have. First one that says, in my country, it is mandatory to recalibrate every year. How successful do you think I can be to waive that requirement? I cannot give you an answer to that, no specific answer at least. It's worth a try. Now, we've had situations where we have gone to local regulators and said, listen, this is the logic why, because don't forget, when a regulator specifies that every instrument needs to be calibrated within a year or within 6 months, they take all the instruments and put them on one big heap. Most of the time, an instrument is not being checked whether there's a need for recalibration at every time that you use it. So if you explain it to your regulator, you may very well be successful. We're more than happy to help you. I will give you my contact information at the end of this presentation, but the fact that you registered for this presentation gives you another opportunity to say, or you know how to contact me. We're more than happy to help you with that and give you an indication of what is possible. What is the industry practice? Well, it varies. There are companies that are implementing a very strict once-a-year recalibration period. There are other service providers that say, listen, we have a problem with it. And their logic goes kind of like this, that they have a large number of different cones. Some of those cones are really not being utilized all that often. because they're for a very specific application. So they are in the truck of the service provider, but you never know how often you're going to use that cone. And it could well be that you don't use that cone more than, say, once every 18 months. And that means that before it's being utilized or used again, you would have to recalibrate it again. And they say there's really no reason for that. If the cone has been calibrated and just been sitting there nicely stored, there's no reason to say that you have to calibrate it again. There are companies that say, hey, forget about all this stuff about the time period. We are going to do it on the use of the cone after pushing so many meters. Personally, I think it's very hard to keep track of this whole thing. Yes, you can keep those records, but it's very difficult to say, was a cone used or was a different cone used? And it's a lot of paperwork. So there's really no standardized approach within the industry where you can say, this is what the industry is doing as a whole. Everybody will meet the ASTM requirements or the ISO requirements regarding the baseline surveys. When it comes to the actual recalibration, it's kind of, some people do it this way, some people do it that way, and that is the way it's probably going to be for a long time. And I don't think that the objective of this webinar should be to convince you to do it differently. The objective is more to explain to you what the logic is, why the code says what it says, and you have a better understanding what's happening. Those are all the questions that I see right now. If you have any other questions, please feel free to contact me. I want to thank you for being here.